Okay, so here are just a few supplemental problems for section 8.4 in geometry for you to look at in case you missed the lesson or forgot how to do it. So they want us to do express each ratio as a fraction and as a decimal to the nearest hundredth. So we're just going to do 1 through 6 real quick at this because it's all the same thing over and over again. So they want us to do sine of angle A, tangent of angle C, cosine of angle A, tangent of angle A, cosine of angle C, sine of angle C. So they're doing all three sine functions and all three functions for angle A and angle C. So let's just start with angle A. We'll just do those, which will be problems then 3, 4, and 1. We'll do those in black. And then we'll do in red problems 2, 5, and 6. We do angle C. So the first thing is sine is opposite over hypotenuse. It's a good old SOHCAHTOA. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine, cosine, tangent, SOHCAHTOA. So for angle A, 16 is the opposite, 12 is the adjacent, and for both of them, 20 is always the hypotenuse. So for number 1, sine of angle A is opposite over hypotenuse, so 16 over 20, which reduces to 4 over 5, which is 0.8. I don't even need a calculator for that, or just the nearest 100 to be 0.80. Number 3 is next. 3 is cosine of angle A. Well, cosine is adjacent over hypotenuse, so it'll be 12 over 20, which is then 3 over 5, which is 0.60 to the nearest hundredth. And then number 4, which is tangent of angle A, is opposite over adjacent, which is 16 over 12, which is 4 over 3, which is 1.33 to the nearest hundredth. Okay, I didn't get a calculator out because I knew those, but just divide them out to get the decimals. Now, for angle C, what ends up happening is the opposite and the adjacent switch. 12 is the opposite, 16 is the adjacent, and the hypotenuse stays the same. So for number 2, tangent of angle C is opposite over adjacent, so 12 over 16, which is 3 over 4, which is 0.75. Number 5 is cosine of angle C, which is adjacent over hypotenuse, so 16 over 20, which is 4 over 5, which is 0.8. And number 6, sine of angle C is excuse me, opposite over hypotenuse, so 12 over 20, which is 3 over 5, which is 0.60. Okay. So there's good old SOHCAHTOA that kind of set up the ratios. Okay. All right, the next one to take a look at is number 8. This is solving for a missing side. Having to do that. Okay. So how we do these problems is you always go back to what did they give you? What side did they give you? Well, in this case, they gave us, or sorry, what angle? Excuse me. They gave us the 52-degree angle, which means x is the opposite and 13 is the adjacent. So I'm trying to solve with the adjacent and the opposite. So we go back to our little saying. Which one uses adjacent and opposite? Tangent does. And that's opposite over adjacent. So the tangent of 52 degrees has to be opposite over adjacent, so x over 13. Which means we solve for x by multiplying by 13, because that'll undo the division. And then we just get our calculator out real quick. And we do 13 times the tangent of 52 on it. Again, make sure your mode is in degrees. If it's a scientific, it should be. If it's a graphing, it won't necessarily be, especially if it's never been used before. So to the nearest hundredth, that gives us 16.64. So 16.64. Okay. And then number 12. Number 12. I can't remember which angle they want us to solve for, to be honest. So let's assume we're solving, well, we can solve for either of them. If we're going to solve for angle, let's say we'll start off with solving for angle x. Okay. If we solve for angle x, we look at our sides that are given to us. 5 is the adjacent, 9 is the hypotenuse. So again, we go back to our SOHCAHTOA, which one uses adjacent and hypotenuse? That's cosine. So the cosine of angle x has to be its adjacent over its hypotenuse. So it has to be 5 over 9. Now, as a decimal, that's 0.555555, repeating forever and ever. If I look it up I just haven't memorized, but if you did it in the calculator, it's that. So what we're looking for is what angle, if I took the cosine of it, would give me 0.55555. Well, to do that, that's when you use, back here, the second cosine. Second cosine undoes cosine. Or you give it the ratio and it gives you back the angle. So I could just do 5 divided by 9 on the calculator. And I get 56.25. Okay. Oops, I'm blocking myself here, aren't I? Can't see it with my calculator in the way. So, yeah. So cosine of x was 5 over 9 equals 0.5555. So I did the inverse cosine of 5 over 9, and that's how I got that angle there. Now, if I wanted to, let's say, I don't know, solve for angle z then, yes, I could subtract this from 90 because those two angles had to make 90 together. But I could also use trig for this and say, okay, this is still the hypotenuse, but now this becomes the opposite. Okay, and so if I have the hypotenuse in the opposite, that means I'm going to use sine. So the sine of angle z is going to equal 5 over 9. Because that's the opposite of our hypotenuse. So I'll now use the inverse sine to undo that work, and that'll give me angle z. So to do that, I go to my calculator, and I do second sine of 5 divided by 9, and I get 33.75. Which if I do add these two guys, oh sorry, I forgot about it. I keep forgetting the calculator's in the way. Which if I do add these two guys together, I get 90. 56.25 plus 33.75 equals 90, and there's already 90 taken care of here, so that gives me my 180 for the triangle. Okay. All right, there you go.